Well, here I am back again. In this exciting episode, number 4, I am going to show you the varied and rich timeout modes that you can have in states when you program Tabula. And you can have a variety of timeout modes without really having to worry much about the code that's being generated. Okay, so to kick off, let's imagine that this push on push off button that we have made is actually being used to control the lights in the stairwell in a block of apartments. So a resident can push the button when at the bottom when they arrive home, and when they get up to the top they can push a second button which is in parallel with the first, and it turns the lights off again. So you've got several buttons but they're all in parallel, and pushing any one of those buttons will toggle the state of the light. But what of course we discover is that people forget to turn the lights off. So we decide that we want to put in a timer. Now where would we put the timer or timeout? It would have to be in state 3, because this is where the light is on and waiting for the second press that presumably is never going to come. So let's put a timeout in here, and we can simply do that by clicking on the timeout mode cell, and it brings up a little window where we can set the timing, when the timing is to start, and on this case it's to start when we enter the state. We will put it in just as a constant, and I'll make it 10 units of time. Now that's 100 milliseconds, but when we're simulating in SPLat PC it becomes a reasonable time just to observe what's going on, because SPLat PC, as you know, is not real time as such. So that's set the timing mode. It will start in when we enter this state. In fact, there's the tooltip. Timing starts on entering the state, times out after a constant time of 10 system ticks. And what to do on timeout? We put in the timeout target column here, cell here, and we want to go to state 4. So if I now go and generate my code like so, switch over to SPLat PC, and rebuild with Control Shift F12, accept the little information things, set the program running, which is Shift F5, and I can now click the light on, and after a short period of time it goes off again. Click the light on, click it off, click it on, click it off, click it on, forget to click it off again, and it times out all of its own accord. Click it on, and now what I notice is that if the switch is stuck on, the light is also stuck on. That would be the scenario if some silly person goes and sticks a matchstick under the switch. So let's go and fix that up in our state machine. We'll go back to Tabula, and we actually also want to start timing in this state, which is where the switch is on and we're waiting for it to be released. So we'll have a transition from there to 4 on timeout, and we will start the timing on entering that state like so, and on this state we will simply just continue timing like so. So now it says we start timing on entering the state, times out after a constant time of 10 ticks. Alternatively, continuous timing started in the previous state, or any previous state, times out after a constant time of 10 ticks. So let's give that a go. Generate, back to SPLat PC, rebuild, ignore those warnings, and set it running. Now I can turn the light on and leave the switch on, and after that time period it actually times out again. So I've got the toggle on, toggle off, toggle on, toggle off, toggle on, toggle off, but if I leave the switch on, it's still going to turn off. Now the interesting thing about that in the apartment block would be if somebody has wedged one of the switches, then all the lights are going to be, none of the switches are going to work anymore, which might punish the idiot who did it. Okay, now let's just say that just for a little bit of added spice here, that we would actually like to control the duration of this by setting some dip switches so that the apartment owner or the apartment building owner can set what that timeout limit is going to be. So instead of having a constant timeout here, we want a variable timeout, and that's going to come from elsewhere. Now there has to be some code somewhere in the program that just determines how that how the time is going to be controlled. Sorry, what the time limit is going to be, and you would generally do that by having a go sub call to somewhere else that sorts that out. So we'll put a go sub. I'm going to call the routine that fetches that time, CNF for configure get time or get time limit. And a call to CNF get time limit, what that has to do, it says here, place the time limit in W as a floating point value. So that's the code that we're going to use. And we also need to have that in this state here because we want that to be variable as well, like that. So this on this state it's going to continue timing, but it's going to fetch that time limit again, like that. So now the code generated by here is going to assume the existence elsewhere of a function or a subroutine called get time limit. I'm going to just generate the code and you'll see what's happening here. There in state 2 it's doing a go sub, it's assuming that it's got the time in W, and then it does its calculation and decides whether to switch states or not. So where are we going to get that routine from? Well, believe it or not, here's one that I prepared earlier. I'll show you this in SPLat PC. Open. It's a separate file called CNF, and I've actually called that get time rather than get time limit. So let me just fix that up and save it. The capitalization doesn't actually matter. What this does, it does an input FM from input 0, so it gets the first 8 inputs as a byte. It takes an F mask 4-bit set and ANDs it bitwise, and then floats the result. So the result from this is going to be a number between 0 and 15 in the W register, which is a function of the 4 first inputs, which are these here, which we might imagine are connected to a dip switch. So let me just save that again, close it. Now the other thing I have to do, yes, I do want to close it, save it, thank you. The other thing I have to do is to fix up my build file to include that file, which I call cnf.spt. So my build file, I've saved that. So that build file now references that file that I had before, which I'll get that back again and just show you. It's got a code seg in there because it's designed to be used for Builder, and it's got its own little header comment and all those good things. So I've saved that. I better make sure that I've generated my code here because I quite honestly can't remember. Code generate. Yes, there's the CNF get time limit. So let's see how that goes. Go back to SPLat PC and do a Control Shift F12. And now we're up to 91 bytes of code, a huge program now. And let's take a look in there. There's the call to CNF get time limit, and down the bottom there is CNF get time limit. So I should now be able to set this running, and you'll notice that it's very fast at the moment for the simple reason that the time is 0. But if I set the time to say 8, now we get a reasonable delay. I can set that to the 4:15 if I want to and get an even longer delay. So you can see that changing the timing modes with Tabula is extremely easy, and you really don't have to worry about the fact that the code to implement that timeout is going to change quite significantly depending on whether it's a constant or a variable that we're using, and whether it's a timer that starts and finishes in one state, or whether it's a timer that straddles several states. It's all quite easy to set up with the timing modes in Tabula, as you see there. Now let me just show you one other little feature of Tabula which I've added since I did the previous video clip, and it's called backtracking. Now you'll recall that I can set a state as a current state, and when I select an event that can take place in that state, I can automatically do the transitions like this. Now let's say, just say we do the timeout here, and we wind up in state 4. Now this is a very simple state machine, of course, so it's pretty easy to see it directly from the chart, from the table, but in some cases we may have quite a number of different states that can lead into this particular state, and we might want to be able to find out what that is. So if I right click on there and look at the context menu, I've got something called backtrack. If I click on that, what I get is a window that shows me for state 4, the let off state, all the ways in which I can get there. I can get a timeout from state 2, I can get a timeout from state 3, or I can get a button press in state 3. And these are indeed the 1, 2, 3 ways in which I can get to state 4. Just to make that even better, I can now pick one of those and say, well, I came from state, suppose I came from state 2, how would I have got to state 2? If I click on the state 2 in this backtrack window, it takes me back and shows me how we can get to state 2, which happens to be a button press from state 1. Now I can go back, click on that. How do I get to get to 1? I get to 1 from 4, and so on. So I can actually backtrack my way through the program in a complementary fashion to tracking forwards when I hold down the shift and move over events here. So I can actually move either way. And incidentally, the code generator will detect if you have an unreachable state. Let me just give this a name, call it 5555. If I now go and do code generation, you'll see I've got a warning that state 555 has no content other than a name and it's unreachable. Unreachable meaning that there is actually nothing. If I go on here and backtrack, there is nothing that leads to state 5. So just before I do anything more damage, I'll clear that out again. And that's it for this session. In the next session we'll take a brief look at the else clause.